You should currently hear some automated thing saying you are now being recorded. Awesome. Stephanie, where are you?
My camera's cracked and it's pretty blurred.
Gotcha. Okay, just making sure you're still there. All right, Pete, where are you? You here?
Hi, I'm here.
Cool. Okay, just making sure. All right. So today, essentially, we're gonna have a fun activity. This is one of my favorite times of the class. So here's what we're gonna do. I want you. Hi, Sophie. How are you?
Oh, sorry. I just had to press like OK with it being recorded.
Okay. Gotcha. Always nice to see a friendly face. So today, what we're gonna do is we're gonna put the logical formalism we've been developing slowly into practice. So I will go over the homework from last week and the exam stuff too. I'll go over all that again. But before I do that, I want to actually use the stuff we've been working with because that's the fastest way for you to get a deep understanding of it. So that by the time I do go over the homework in the exam, you're gonna be like, dude, this is old hat. I already know how this works now. So we're gonna actually be doing, or you're gonna actually be doing a lot of like creative thinking today in terms of the formalism. Here's what I have in mind. I'll do like a cursory run to show you what I'm thinking. So you're gonna take a relation, maybe more relations, and you're gonna take predicates. Maybe hello. What's up?
You can finish.
Oh, okay. Well, that's fine. Do you have a question?
Can you like record like all of your lectures?
I can from here on out, but unfortunately I can't go back into the past.
Yeah, that's fine. Like from here on out. Oh, I spit all over the computer. I'm so sorry.
That's okay. That's fine.
That would be really helpful because like, yeah, I was really sick like the last week and like I don't know what's going on. I got like a 1 on the exam.
Oh, really?
Yeah.
I don't care that much about the scores, so
I do. It's embarrassing.
But we can talk about it more, and if you're really concerned, if what you're concerned about is not understanding the material, now I'm concerned. So, but I'm not surprised because the exam was hard. So.
Yeah, it was very difficult. Thank you for understanding. Have a good day. I'll try to see you on Zoom.
Awesome. Okay. Just FYI, by the way, like we're at the point in the semester where I can go ahead and confide in you because you've earned my respect if you've made it this far. The exams and homework questions are like graduate level questions. I do that on purpose. So I'm not surprised that you're not getting that. That's why I've said that again and again. I'm not surprised because graduate students would have trouble doing this. So I do that on purpose. So you can see all the places you can go wrong. But it also helps, I've found in my experience, I've found that failing in this way again and again and again helps build your mastery of the material much faster than if I just gave you some softball questions that test you on things you already know. Like, oh yeah, what's about, or you probably pick one out. It's not that important, or not that difficult for you. I want you to be challenged, like elite level challenged again and again and again, because you'll rise to the occasion. So anywho, now we're gonna rise to a different occasion. I want you to pick some predicates, some relations, and model a domain of inquiry. What do I have in mind? I'll give you an example. So I'll show you. I'm gonna pick the domain of everything. You don't have to pick such a big domain. You could restrict your attention to humans or chairs or bowls of sweet and sour chicken, whatever you want. I happen to have been eating sweet and sour chicken just before, so it's fresh on the mind. You're more than welcome to restrict your domain however you like. What that means effectively is that when you pick a domain, you're saying whatever you're restricting to, that is the scope of this quantifier. So in this case, when I say my domain is everything, that means everything goes in here, unless I restrict this in some way by using predicates. Now, if you are just thinking about tables, if your domain is tables, then the scope of your all quantifier is just tables, okay? So this is to say you don't have to, for instance, introduce a predicate like to say table, like an uppercase predicate. If you're restricting everything to tables, because that would be redundant, everything is just a table, right? As far as you're concerned. Does that make sense? Cool. So that's the first thing. I'll pick that domain. You can pick your own. I'll pick predicates. Oh, well, I'll call them vocabulary. Full of predicates and relations. Now I'm going to stick to just some relation, or just one relation. It's called parthood. It's to place. Oops. Is part of. So things are parts of other things. My elbow is part of my arm. My beard is part of me. Like table legs are part of tables. Like I claim in many things bear parthood relations to many other things. It's a big domain, or it has a wide scope. That's why I listed my domain as everything, because parts come up all over the place. So when I say that, this so far allows me to make claims like this. You know, something has a part, or everything is part of something. Now, I'm not saying these claims are true. I'll have to do some more work to flesh that out. I'm just saying with this vocabulary so far, I can make these sorts of claims. Now, I am going to do some critical thinking real quick about what it is that I want to, or what exactly does let me rephrase that. I'm going to do some critical thinking real quick about what exactly the natural language meaning of is part of amounts to. I will do that in the following way. I will be reflecting on what sorts of restrictions, logical restrictions, one might impose on is part of to give it meaning. Because as it stands right here, if I just write P and then put some variables, that has no restrictions unless I tell in the language that, or impose in the language some restrictions. So right now, it could be the case that this is true. If X is part of Y, then Y is part of X. That could be a general truth as far as the language is concerned because I have not placed any restrictions on it. Now, hopefully it's intuitively obvious that it's not the case that if something is part of something else, then the second thing is part of the first. My elbow is part of my arm, but my arm is not part of my elbow. That's not what the word means. That's not what the expression is part of means. Does that make sense? So how do I go about imposing restrictions? I will assert axioms about parthood, or alternatively, axioms that govern parthood. Here is one. For all X and Y, if X is part of Y, then it's not the case that Y is part of X. This is, you could describe this as asymmetry. It's not symmetric. That is, parthood is not symmetric. In contrast, I'll show you if you have a relation like is next to X is next to Y. This is symmetric. So it would be true to say if X is next to Y, then Y is next to X. That is true. But parthood is not that sort of relation. For parthood, if one thing's part of the other, the second is part of the first. Now, you might be thinking, in sort of boundary cases, like, hey, what if you're talking about the same thing? Like, what if X is Y? It's true. But we got to introduce a definition to account for that sort of meaning as well. We don't want those sorts of examples to get in our way. So we will also, in addition to this parthood relation, introduce what's called a proper parthood relation. And we will define it in terms of parthood. Easy peasy. What is proper parthood? I'll define it for you. proper part. X proper part of Y equals X part of Y, and well, here I'll just use the logical and X is not equal to Y. Does that make sense? No, this is just to say there is, a little ambiguity in natural language when we're talking about parthood. You might want to talk about parts, or like proper parts, things that are actually just smaller than the thing they're part of. And maybe you also want to talk about things that are the exact same size as what they're part of. Both of those seem on the table. So we can introduce, though, just by logic, a definition that accounts for the proper part of relationship in terms of part of relationships. So we can start with one and get the other easy peasy. Of course, we also introduce this identity symbol. It works just like you think. We'll actually come back to that one. Of course, here, why I even did this might not be so obvious, but I'll explain. So I'm going to claim for everything, it's part of itself. This is reflexive, or reflexivity. I'll let you think about that for a second. See if you agree. I'm making a claim about how is part of works in natural language. And I'm saying, in natural language, everything is part of itself. It's in fact the maximal part. So I am part of myself. That makes sense? Any objections? Usually I get some objections to this one. Sweet, awesome, let's roll with it. If you needed any motivation, I would just say something like, okay, look, my toe is part of my foot. All right, my foot is part of me, right? If you keep going, you keep expanding until you get all the way to the tippy top, to where like everything on me is part of me except like my eyebrow, and then you add in my eyebrow, looks like you've got me. It looks like you also should say that whole thing is part of me, therefore I'm part of myself. I'm the maximal part, the biggest part. But hey, nobody's pushing back, so let's muscle through. There's another relation, or another aspect of this this natural language relation worth pointing out. It's called transitivity. It works like this. Probably the most known or recognizable aspect of parthood. If X is part of Y, and Y is part of X, then, I'm sorry, if Y is part of Z, then X is part of Z. This is transitivity. My elbow is part of my arm is part of me, therefore my elbow is part of me. Parthood check. That should be pretty good. So far, we good? Do you see what I'm doing by imposing like axioms to constrain what is part of means? That's one question. The second one is, how do you feel about the constraints that I'm imposing? Insofar as you understand what is part of means in natural language. All right. We good? Hell yeah.
Makes sense so far.
Good, good, good. So now you're going to be doing the same thing. Just you may use parthood, you may use something else. So it's important to be a little careful. So I just introduced a contradiction in my axioms, and nobody picked it up. But that's fun. This is just left. This will become more apparent as you play. So recall that I have imposed so far the following 3 axioms. Oops. I claim you can generate a contradiction. You can actually prove a contradiction from these 3. Anybody see it?
What did you say?
I claim that you can prove a contradiction from these 3. They can't all be right. I've attempted to impose these on the natural language understanding of is part of, but I'm telling you there is a contradiction here. I can't keep all 3 of them.
Is the contradiction the first and the second?
Yes. Would you like to elaborate?
I'll try.
Go for it.
So if X is part of X and then it's like everything, then Y has no part of it, basically.
That's it. So if you put these together, then it follows that because everything's part of itself, something's not part of itself. Contradiction. That don't work. So that's great. Very good. So I'm pointing this out because this is probably going to happen when you're trying to impose constraints on natural language. You'll do this. Everybody does. It's fine. So now you have to make a choice. Which one do you get rid of? Because you can't keep them both. I'm going to get rid of this one, but I'm going to replace it with something that's nearby but weaker in strength. So this is pretty strong. It's strong enough that it got me a contradiction. So I need to introduce something a little weaker that still kind of captures what I'm after. So intuitively, I want to say that if X is part of Y, then it's not the case that Y is part of X. I can't directly say that. So here's how I'm going to approach it. I'm going to introduce this. This is called anti-symmetry. It is weaker than asymmetry. It just says that whenever you have, whenever it's clear that X is part of Y and Y is part of X, then those 2 things you're talking about are actually just one thing. This doesn't get you a contradiction in the presence of the other axioms. Now I'll let you, if you're interested in working that out, I'll let you work that out on your own, or I'll just send you, my proofs. I've got talks on this I can give you. But here the important point is just to note, if you get a contradiction in your axioms, not all is lost. You may just need to think about how to weaken one of your axioms. In this case, the way just FYI, the way I weakened it was I added things to the antecedent. That is always a way to weaken your axiom. The more you have up front, the less it applies to. Because remember, this part really constrains the scope of your domain. It constrains what you're talking about. So if you add more in, then you're saying less about things, or you're talking about less objects in the domain, because fewer things will meet this constraint. And that is a great way to avoid a contradiction. Don't worry if that's not like completely driving. That'll come with practice. So one other thing I want to point out, and then I'll leave you to it, is if you look at these axioms that I've introduced over here, you can think about this in terms of proofs as well. So for the first one, you can, just like we did with conjunction introduction or conjunction elimination, all that, you can turn these things into proof rules. Here's how you can do it. So here's a proof rule for reflexivity. You have on any line, you can infer something is part of something as part of itself. So from no premises, this just says you can always write that down anytime you want. So for the what we call anti-symmetry, this says that if on one line you have something as part of something else, and on another line you have the reverse situation, then you can infer that A and B are equal. This is anti-symmetry. And finally, if you have on one line PAB, for instance, and on another line PBC, where they are all different, then you can infer PAC, and that's transitivity. You can do this with any equations or any axioms that you come up with too. The recipe is just this. You take, if you have no conditional, then you're just saying that on any line you can write something's part of something else, whatever your predicate applies to. If you do have a conditional, then you just put in the antecedent as the input, namely your premises, and the consequent as the thing you infer from them. Same here. Both of these get you that. That's the recipe. And if you want to check whether your axioms are in conflict with one another, you can put them together with the proof rules you construct and just try to prove a contradiction. And if you can, you know something's wrong. So does that make sense so far?
No.
No. Which can you tell me where I lost you?
You went a little bit too fast.
Okay, which part?
The whole time.
What's that?
Like we just did. You know that?
This the proof part?
Yeah.
Okay. So I'll go through it one more time. I'll do it a little slower. So all I was saying, I'll just use this one as an example. I said if you come up with an axiom that you think governs, your natural language expression, it's in this sort of form, namely it's a conditional, that you can turn this into a proof rule if you just put the antecedent on top as premises, and then put the consequent as the thing that follows from those premises. So you're just breaking it up. You can think about it, just taking it from one line and making it a couple more, right? And this is the valid proof rule for you. And if you find yourself checking or wondering whether or not your axioms are consistent with each other, you can put them in proof rules like this, and then try to prove a contradiction. Because if you can prove a contradiction, then you know they're not consistent with each other, something's going wrong. And then you got to pick which one you want to get rid of or weaken. Does that make sense?
Yes.
Awesome. So I suspect you won't have grokked all of this, but that's okay. Again, this is like go do it. You'll get better at it, and better at it, and better at it the more you practice. So here's what I want you to do. First thing, pick a domain. It can be whatever you want. And then pick your vocabulary. And then after you do that, think about whatever, with respect to whatever your vocabulary was, think about what constrains that vocabulary. I gave you one example of partly. Another one was next to. An axiom that constrains that is that it has to be symmetric, right? If x is next to y, then y is next to x. That's just what it means in natural language. So if you pick next to, then I expect an axiom reflecting that in your characterization of next to. Okay, so I will be ready to work together. If you have questions, come ask. Hey, Zoom folks, would you like to do groups on this? Any preference?
What did you say?
Would you guys like to work in groups on this?
Yeah.
Okay. Yeah, everybody else is good? All right, let's do it.
Based on the domain.
So,
We had terrible feedback when you were describing the directions of what we were doing. So could you possibly restate what we're supposed to be working on?
absolutely. So I'm yeah, I'm not sure how much you did catch. So basically, I'm hoping for you to pick a domain that you want to model, and then identify predicates and relations in that domain that you think will be useful.
Okay.
So I was using the example of parthood. Now, my domain was everything, but you could have a less restricted or a more restricted domain. You could pick like students in this classroom, right? And then you might pick predicates like, or predicates and relations like is taller than, or has hair,
Okay.
or is going to pass. In which case, of course, everybody is going to pass, right? So, right. But like you can pick predicates and relations like that to help describe the domain. I'm not looking for you to do it exhaustively. There's way too much, especially if you pick a restricted domain like that. There's too much to go through, but just like these are baby steps into it. And then when you do that, when you pick your predicates and relations, I'm hoping for you to impose constraints on those relations to make sense of the relations in the formal language. So the way I did that with parthood was I was like, look, everything's part of itself. It seems true, so I have to say that explicitly. There's some kind of like lack of symmetry going on with parthood. I got to say that explicitly. Transitivity, there's some kind of transitivity going on with parthood. I got to say that too. You might also think about like is taller than. Just think to yourself, well, is anybody taller than themselves? Well, no. So I should probably say that explicitly. Like it's not the case
Okay.
that someone's taller than themselves. Also taller than is transitive, right? If you're thinking about like if you want to describe colors, for instance, you might like red, the color red, like maybe you want to say that something in the class is red. It's probably a good idea to say something in addition to that, like anything that's red has a color, right?
Okay.
So that's not a relation, it's just a relationship between two predicates, but it also seems true, right? Everything that is red has a color, so it's good to say. Does that make sense?
Yes.
Nice. Let me check on the other group. I suspect they had feedback as well. Hello. How goes it, Team 2?
It goes okay.
Yeah.
Here.
Wrote some stuff out. I'm reluctant to share it, but I will.
That's okay. Have your teammates helped you out?
Here and there.
Okay. I hear from you a lot, Scott, which is great.
Yeah.
So I would like to hear from your teammates a little, if that's cool.
Okay.
I'm not trying to pick anybody out. I just want to make sure you understand what I'm doing, because that was kind of fast. So this is like a comprehension check. It's totally fine if you didn't pick it up all. I just want to make sure you get as much as you can.
I'm like confused on like, can you give it like for the vocabulary part? Like that's where I kind of got stuck.
Yeah, no, that's where all the meat is, right? Like, so say you pick a domain like flowers or something, which are incredibly hard to model. But say you pick a domain like flowers and you want to describe them. So your domain is flowers, and your vocabulary, you're going to think about the properties that flowers have. So like, for instance, many flowers have petals. Many flowers have a color. Some like tulips are violet sometimes, right? So you might want to say stuff like that. You also might want to describe them, like the relationships among them. So for instance, you might want to say that one petal is bigger than another, or one petal is part of a plant, or maybe one plant is taller than another, or a tree is taller than another. And so when you impose like new meanings into your interpretation like that'll be part of your vocabulary, those relations and predicates. You also have to like make sure that you're real explicit about what those predicates mean and what those relations mean. And the way you do that is by introducing axioms, like I was describing, the upside down A and stuff. So for instance, just relating one predicate to another, you might say anything that is purple, any flower that is purple has a color, right? And so you'd want to link purple or being purple and with having a color. So there's two predicates. And then with relations, let's say like taller than, if you want to say one tree is taller than another, you have to add meaning to the taller than by saying things like, well, nothing's taller than itself, right? So I got to say that. If one thing's taller than another thing, then that, and that second thing's taller than a third, then the first thing's taller than the third, right? Transitivity. And so we're just kind of like adding content that we know is true to make sense of those relations and predicates. Does that make sense?
Like, yeah, it makes sense when you say that, but then it's like, so what was like right now, what was the goal of this activity? Because like to write all that out, what you just said, or like
well, I mean, you can if you understand it. So but here, what I was hoping you to do is you'll pick a domain, like whatever you want, like pick what, like hats. You pick hats, like you want to model hats, and then you're going to introduce predicates and relations on your own. Like you just sit and think. You're like, what properties do they have? Now you guys can do this in a group too. Like you don't have to do it independently. Just talk it out. Like it's always a great idea to brainstorm these sorts of things, because you might forget some properties. Like hats. Hats have like a bill on them, and they have colors, and they have like designs often. Like these are things that you can introduce into your vocabulary. And you can just think about it as like, in terms of vocabulary, like how would you talk about them? If you were describing a hat to somebody, what language would you use, right? And imagine you're describing like, or stick with like the tree example. Imagine you're describing two trees, one taller than the other, and you're describing like the wood and the branches and everything. And then you forget to mention that one is taller than the other, and the person you're describing it to, because they're not bright, goes, oh, so they must be the same height. And you're like, no. And then you think to yourself, well, I guess I should say those things explicitly because this person has never seen a tree before, right? But that's like the goal. You don't have to be that like too explicit because this is baby steps. But I would like opening salvo, picking a domain and just trying to model it as best you can, using a vocabulary of your own creation. Does that make sense?
Yeah, so like let's say we were doing like tape or trees, and then our vocabulary was taller. Like for like when you were doing everything in the part of, you did like P2, right?
Yeah, that was just in the 2 was just to indicate that this vocabulary letter relates one thing to another. And then if it has a 1, it was just like, that was just to say that it's a property. So just one thing goes in there, like is bald. It's not a relationship between things. It's like just what I am, right? I'm bald, so I go in there, right?
Okay. So for taller, would you just do a T?
So it would be, yeah, you could be a capital T. Now you can make up whatever letters you want for them as long as you're clear about what you're talking about. But yeah, it'd be a capital T, and then you have a circle with 2, because taller than relates one thing to another thing. That's right. Yeah.
Okay.
All right. How's everybody else doing? Stephanie, Pete, you have any questions?
I mean, after you explain, I think it's better.
Oh, good.
Thank you.
Yeah, of course.
Yeah, I think that cleared it up, but it'll still just like working on it.
Yeah. Awesome. It's just practice. Like you'll get better at it. But I'm glad to hear it's cleared up. Okay, I'm going to check on the other group, and I'll be back. What's up, respective fams? I'm going to say that forever. It makes me laugh. Do you guys know who Clint Eastwood is?
The actor?
Yeah. I was talking to somebody who was young yesterday, but not that young. She's about your age. And I said Clint Eastwood, and she's like, I don't even know who that is. And I said, I don't feel old. I just feel like you're uninformed.
Yeah.
Anyway.
I feel like I've never seen anything with him in it, but you should definitely at least have heard of the name.
Yeah. Honestly, I've never seen anything with him in it.
What?
I really haven't. it's not my cup of tea.
He does a lot of country old Western movies, right? Yeah, not my
Yeah.
Angry person movies. They're not my thing. Just like mad all the time. Like,
Yeah,
why
but
are you
at
so
some point
mad?
you
You're
gotta
rich. What'd you say?
At some point, you gotta watch one.
I really should. I mean, he's iconic. I feel like I get so much of like the iconism from pop culture anyway. Like I could pick him out in a crowd, Anyway, enough about Clint Eastwood, unless we're modeling him. How's it going?
I think we have a domain, and which is animals. Not entirely sure if we all have the same vocab. I have can fly and is a mammal. That's the one that I'm using.
Cool.
At least for myself also, I'm trying to make restrictions where if for all X, right, if X is an animal, if it can fly, then it's not a mammal. And if it's not a mammal, then it can fly.
Ooh.
And then I'm also saying that for some X, it cannot fly and it's not a mammal.
Yeah.
And so I'm saying that, but I'm not entirely sure if I'm correct on the what's it called, the universal and the more specific, I forget what it's called, but the E. I'm not sure if existential, I'm not sure if my application of those is correct.
I'll tell you how you can test it. Just pick a small domain, like of 2 things, and then expand it. Like pick one flying thing that's not a mammal and one mammal that's not flying, and expand it, like replace it with the existential and the universal, like we've been doing, and see if the resulting sentence is true.
Okay.
If your axioms not exactly right, you should be able to construct a counterexample with a small domain.
Okay.
Also, I mean, this might be too sophisticated, but if you wanted to know, I'm a mammal who can fly. I just flew over the weekend. So, logic is dumb, man. You gotta be real careful.
Right, I understand. Okay.
Awesome. All right, I'll be back. Let's see. What's up? How's it going?
It's good. Honestly, big no idea what we're doing.
Did somebody say
Were we just supposed to make restrictions?
Say that again?
Were we just supposed to make restrictions?
Well, you're supposed to pick a domain, and then pick a vocab, and then put restrictions on the vocab. So let's say your domain is flowers. You want to describe flowers, and you can think about it like you're trying to describe flowers to somebody that's never seen a flower before. So you're gonna what sort of language would you use to describe them? Well, you probably want to say things like it has a petal, has a color, you know. Let's see what else is taller than. You might want to say that one flower is taller than another. And when you do that, you gotta like impose restrictions on these things. So, and that may lead you to add more to the vocabulary. So, for instance, if you're thinking about what a petal is, you might want to also add something has a stamen, and then say stamen not the same thing as a petal. Gotta be real explicit. Alternatively, that might be one restriction. You might want to also say something like, if something has a color, it could have a specific color. Most things don't just have color. So you might want to introduce is red, and then you might want to say, if it's red, I'll just say this is red here. If it's red, then it has a color. And that'll leave these two predicates. Because it's true, anything that is red is a color.
So is there a restriction that is red, or is it everything that's red?
Yeah, the restriction is the whole axiom. So like everything from here onto closing brackets. So that's the restriction. And you're like placing it on the meaning of the expression. It's a restriction on like what these natural or what these things in your vocab mean. For instance, is taller than is probably one of the easier ones. So you probably want to say nothing is taller than itself. You probably want to say for everything x is taller than y and y is taller than z, then x is taller than z. And these whole expressions would be constraints on the
Oh, so is a restriction and a constraint the same thing?
Yeah. Sorry, did I use both?
Yeah, that's fine.
Sorry about that.
Okay.
I didn't realize it was one of my, well, friends, foes, and family. It was great seeing you. Thank you for bearing with me. We're going to pick this up again. Again, more practice you do with it, the better you'll get at it. So don't feel too frustrated. I mean, feel a little frustrated because it's a great motivator. But yeah, I'll see you.
Okay, thank you.
Thank you. Thank you, Sophia.
Yeah.
I'm gonna buy you a jacket.
What?
I'm gonna buy you a jacket because you stayed.
Thanks.
I'll reach out and see if I can yell at somebody.
Yell at somebody?
Yeah, because of the temperature in there.
Oh,
Let me
okay.
stop recording
Yeah.
this so I don't